My name is Mitko, and today I'm going to talk to you about extracorporeal shockwave therapy, which is a non-invasive treatment that involves the delivery of shockwaves to the musculoskeletal areas of the body. So how does that device work? Well, the shockwaves are created at the base of the shock tube, and then they are created by an electromagnetic acoustic source. After they're created, those shockwaves are transmitted through the water into an acoustic lens, and that lens focuses all that acoustic energy at a concentrated point, which is at a fixed distance from the lens. And shockwaves are very short bursts of acoustic waves that are created, as I said, by electromagnetic generators. But in physical terms, shock waves can be seen as series of short and definite fluctuations of acoustic energy, and that transmission is actually characterized by really sudden increase to its maximal pressure at the positive phase, and then a slower decrease to normal levels, which eventually goes to negative pressure at the negative phase. As we can see here in the picture, the acoustic signals make tissues absorb, transmit, propagate the acoustic energy, and all the tissues, different tissues varies in their levels of how much they absorb or transmit the shock waves. Positive pressure and the following negative pressure create compression in the beginning, and then they create tensile forces and also shear stress, which in these forces together combined create therapeutic effects on the target tissues. So now let's talk about the biophysical effects. How the shock waves create therapeutic effects, it depends on the micro and mechanotransduction theory. Shock waves as mechanical forces apply pressure on the extracellular matrix, which creates deformation and fluid flow, and also they continuously alter the cytoskeleton through sensory input into the cellular membrane. Another way that mechanism works is through ion channels, which open because of the pressure, and that causes influx and efflux of different ions that stimulate various signaling pathways. As a result, the cell starts to change their gene expression, and that promotes the increased mechanical stresses. In conclusion, extracorporeal shockwave therapy is very useful for conditions such as patellar tendonitis, osteoarthritis, even non-union fractures, because these shock waves create connective tissue healing and also skeletal regeneration because of their effects on fibroblasts, osteoblasts, and chondrocytes. Thank you.